Good afternoon. Welcome to ASHRAE 36 Demystified. My name is John Douglas, and it's my pleasure to introduce our speaker for today, Bernard Clement, Portfolio Leader, Healthy Building Solutions for Johnson Controls. Bernard Clement is among the world's experts in global HVAC strategy, having lived, learned, and worked in 3 continents, North America, Europe, and APAC, across his 25-plus year career at Johnson Controls. Bernard's areas of expertise include market strategy, new product launches, sales enablement, and advancement HVAC applications, including new technologies. Bernard has a Master's of Science equivalent from a leading engineering school in France, as well as an MBA in finance from Marquette University. Bernard is a member of the International Code Council Pandemic Task Force, the American Conference of Governmental Hygienists, ASHRAE, and ASHI. Bernard is working closely with IWBI, a WELL AP advisor for Air Concept and WELL faculty. A native of France, Bernard is fluent in English, French, and Italian. He is currently based in Milwaukee, Wisconsin. Welcome, Bernard.
Thank you, John. Good morning, good afternoon, good evening. Thank you for being here today. For the first part of this presentation, I will cover the benefits of ASHRAE Guideline 36 and why it does work. Then I will look at how BAS can participate in deploying ASHRAE Guideline 36. In the next webinar, live from AHR, we will get more in details of applying the guideline to a real project. At the end of today's session, we will open the stage to questions from the audience. What is ASHRAE Guideline 36? Guideline 36 is often understood only as an energy reduction tool. I believe that this is an energy reduction tool, a healthy building improvement tool, and a building lifecycle tool. By speaking the same language from design to operation, it enables us to drive the cost down. Design engineers communicate clearly the need to the control company. Control companies design what the engineer needs and that the commissioning agent is intending to tune and validate. By repeating similar application over and over, we become more efficient and reduce our cost. How often have you been at the commissioning stage of a project and found out that what the control company provided did not exactly match what the engineering company requested? ASHRAE Guideline 36 is not a standard. It is a guideline. While a standard defines the what, thou shalt, a guideline defines the how. The purpose of the guideline is to collect all the best practice in the industry and documenting, leaving the room to engineers to customize to end users' need. Engineers need to pick and choose the options to operate the building, a little like you do today for an economizer, for instance, where you choose the enablement strategies. We need optimization because occupancy of building varies greatly. We design HVAC system to be working at maximum capacity. The hottest day of the year, with the office full. How often does this really happen? A pre-COVID study from the ASHRAE shows that system operates at minimum capacity a large percentage of the time. And since COVID, the variation in occupancy between middays of the week and Fridays have significantly increased. The graph above from February 2025 shows that on average, the maximum occupancy in the US is about 64%. And on Friday, it's only 35%. Why should a building run the same way on Tuesdays and on Fridays? That's what ASHRAE Guideline 36 helps solve. What are the KPI that we should be looking at, and how do we meet these? First, the national laboratories such as Pacific Northwest National Laboratory and Lawrence Berkeley National Laboratory have worked over 15 to 20 years to document the solutions and strategies that reduce energy consumption in building. It's based on 4 very basic principles. If you don't need it, you turn it off. If you do not need it full power, you turn it down. You don't heat and cool at the same time. and you avoid bringing outdoor air when not needed. There will always be the need for improved solutions to reduce energy consumption, but the main ones are here. ASHRAE Guideline 36 is a proven method of deploying airside optimization. Some of the strategies stands out as being more operational than control related, in particular schedules. But what we see in the field is that either schedules are missing or the usage of spaces has changed, but the schedules has not. We also see that the schedules has been put in override for the event that happened 6 months ago, and people forgot to release the override. We also see on the graph that the minimum outdoor air reduction is not as impactful. Damper failure is one of the top failures in the industry. It has many causes, including damper being closed or boarded. As a result, when analysis was done, returning to normal operation may lead to increased energy consumption. PNNL has done some study on measures that have the most impact on energy reduction while maintaining environmental conditions. First, the study was theoretical, and then it applied to a portfolio of 151 buildings from the federal government, evaluating both savings and prevalence. The prevalence is the frequency at which an improvement may be beneficial. Based on this work, they have identified that 10 measures accounts for 75% of energy waste. All of these measures are covered by ASHRAE Guideline 36. While other measures might be beneficial, their individual impact and prevalence is usually rather small, and the likelihood of it being beneficial in a building requires further analysis. It might be beneficial in building A and not in building B. Airside optimization is providing the lowest energy consumption for a defined level of comfort and IAQ at a certain level of occupancy. Reducing energy consumption is super easy without the appropriate KPIs for comfort and IAQ. The real technical benefit of the guideline is coming from a holistic approach to the system, not looking at the individual component. When I started in the industry, each equipment was looked at individually. We would control the chiller plant to provide water at 45 degrees. And then we would look at the AHU to take the 45-degree water, convert it to 55-degree air. And then the VAV would do what it could to provide the 72-degree ambient. Since the equipment was sized for the hottest day of the year, it could always meet the 72-degree at full capacity. But at low capacity, it would provide too much 55-degree air and the feeling of being cold. What ASHRAE Guideline 36 is doing is looking at the problem the other way around. The zone measures the deviation from the temperature and or CO2 set point to estimate level of ventilation required and cascade the need to the air handling unit, which in turn cascaded to the chiller for what is needed. As you can see, the algorithms used by each of the plants are not new. We have used them forever. Actually, the newest one might be dual maximum airflow. And even this one was developed over 10 years ago. We will look at this one more in detail later. But what is really new is that they've been worked and coordinated amongst themselves. Today, we will focus on the airside distribution system, as this is where most of the savings are, and most of the standardization can be beneficial. For information, Johnson Controls implementation of Guideline 36 include both the airside and the water side. The system we will be talking about is a hydronic system consisting of an air handling unit and multiple VAV boxes serving the various spaces. We will now go through the 4 most impactful measures documented in the guideline. First, dual max VAV control. This is reducing airflow when it is not needed. A traditional reheat VAV box are set with minimum airflow at 30 to 40%. We control the cooling based on the zone temperature. If the temperature increases, the damper will open to compensate. The minimum airflow is set to satisfy ventilation at full occupancy, which again rarely occurs. By reducing the minimum airflow to 10%, we can save significant energy. Notice that the maximum cooling and maximum heating airflow remain constant. These have been defined by the maximum capacity of the system. Also, in a traditional system, when load required is below the minimum capacity of the system, the room temperature gradually decreases until the reheat valve kicks in, running the system at the heating set point. Have you ever felt cold in the summer season in an empty building? Dual Max, on the contrary, will operate at cooling set point, thus improving comfort. Some might ask, will the VAV box control at such a low flow? ASHRAE did some testing with all VAV box manufacturers, and all of them were able to control slightly below 10%. And even if you had a challenge, the guideline implement time average ventilation. This is like pulse width modulation for the fan. It is authorized by ASHRAE 62.1 and has been validated in the field for not impacting occupant with noise. You will hear people say that trim and response is the central tool to deploy airside optimization, in particular using ASHRAE Guideline 36. Trim and response is a very simple and elegant solution that enables each terminal units to tell central plant what they need. Let's imagine a VAV box that controls the amount of air it provides in the space. As long as this VAV box is able to meet set points, it continues doing its job and controls the amount of air in the space. But when the VAV box gets close to its maximum capacity or is not able to meet set point anymore, it tells its serving AHU, I need more air, I need colder air. This is called a request. The AHU takes into consideration all the requests provided by the various VAV boxes and every few minutes. If every VAV box is happy and able to meet set points and no requests are being made, the AHU will try to trim the amount of air it provides. If some VAV are unable to meet set point, the AHU will receive some requests and respond by increasing the amount of air. The AHU continuously adjusts what it delivers to the terminal unit to meet each individual needs. This mechanism can work with static pressure and supply air temperature between the VAV and the AHU, the reheat water temperature between the VAV and the boiler, or the cooling water between the AHU and the chiller. We're going to look at the two main implementations that are in the guideline. The first one is static pressure reset. Remember that most buildings operate at middle to low capacity most of the time. It is frequently running at 50%. Typically, in the air distribution system, we maintain a static pressure of about 2 inches of water to ensure that the air from the air handling unit is reaching all the spaces in the building. This can be wasteful when every room load requires its damper at 50%, creating an artificial pressure drop. We could then open all those dampers wider to reduce the pressure drop of the VAV system, creating a system with a lower pressure drop requirement to serve all the spaces. For instance, 1 inch. When running at 50% airflow, this could represent as much as 30 to 35% ventilation energy reduction. Static pressure reset has been done for several years. Some do it based on maximum damper position. Some assign damper position to generate requests. ASHRAE Guideline 36 method is based on damper position, but adds the requests if the VAV cannot reach the required airflow. This will allow to get back to the required airflow faster when needed. The other algorithm that uses trim and response is supply air temperature set point reset. That is intended to allow the economizer to run more often when the load is the space is not at full capacity. If my load is at 50% of full capacity and my outdoor air is at 60 degrees, we can increase the supply air temperature to use the economizer instead of using mechanical cooling. But if we were at full capacity, we then revert to using mechanical cooling because the outdoor air would not be able to meet the load. Again, supply temperature reset has been done for years, either based on outdoor conditions or load in the space. ASHRAE Guideline 36 goals. ASHRAE Guideline 36 goal for supply air temperature reset is to maximize the economizer use and to reduce the reheat at the VAV box. Supply air temperature reset developed by the ASHRAE Guideline 36 account for how far from set point the room temperature is and for how long. 2024 revision of the guideline include options for reset based on outdoor dew point. This can be appropriate to be used in areas like the Southeast where humidity is high. Finally, the last critical control strategy is demand control ventilation. It's very simple in principle, but complex to implement in a multi-zone system. Demand control ventilation refers to the portion of outdoor air brought in the space. It is defined in ASHRAE 62.1 for commercial buildings. Traditionally, we have controlled this amount of outside air by putting a sensor in the return air of the HU. While this would work on the average of all zones, it does not ensure that every zone is appropriately served in outdoor air. And you have heard during the pandemic how important outside air is. We might have a room that is fully occupied and another that is empty. The fully occupied room will have a very high level of CO2. The empty room will have a level of CO2 comparable to the outdoor. When measuring the return air, we mechanically average between the two spaces, and we're not providing enough air to the fully occupied space. Demand control ventilation in ASHRAE Guideline 36 is driven by a mix of damper position and fan speed. These two-dimensional problems adjust the damper position between max and min value defined as a function of the fan speed. We have talked a lot about why ASHRAE Guideline 36 reduces energy and improves comfort. Now I will give you one example of why this sequence also improves indoor air quality. As we all know here, air of different temperature behave differently in the zone. As a result, contaminant concentration vary in different air distribution pattern where air changes from hot to cold. Hot air tends to stay in the upper part of the room unless distributed at high speed. ASHRAE Guideline 36 account for those changes in the application, thus improving indoor air quality in the space. Earlier this year, a new version of ASHRAE Guideline 36 was released. As ASHRAE Guideline 36 is on continuous maintenance, we should anticipate update every 3 years. There are still a lot of application to cover and lots of validation required and bugs to be fixed. 4 important add-ons in this revision includes addition of humidity limiting strategies for reset that better match with ASHRAE 90.1 requirements. Addition of pollution mode for wildfire and ozone layers. Addition of various sequence based on field experience and inclusion of demand limiting as we see those coming into code more and more. It is important to note that this is a guideline, but it's also finding its way into the code. California and the federal government have included it in their code. starting in January 2026, California is mandating that every job except healthcare would implement several features of ASHRAE Guideline 36 on the air side. California further asked to use certified program library, and Johnson Control is going through the certification process right now. But we also see other standards that recommend the use of Guideline 36 as an example of deployment. In particular, ASHRAE 90.1 has 31 references of Guideline 36 in their latest revision of 2022. While the Guideline 36 is not specifically called in the code except California, very similar features are called in the code. And it can be beneficial to implement the proven method defined in the guideline. Example, most of the code states that static pressure reset needs to be implemented based on zone requiring the most pressure. Guideline 36 documents how to do it based on damper position and airflow need. Why reinvent the wheel? Note also that most states nowadays requires FDD to be implemented in building over 100,000 square feet. Guideline 36 defines these faults. So Johnson Control is a BAS company, and what can we do to enable Guideline 36? Well, you understand that all those applications are a little bit more complicated than it used to be. But most manufacturers, and certainly Johnson Controls, have developed easy way to implement those sequence. In essence, control engineer select the options per the specification. The code is already written and tested. Only options are being selected. Are we using ASHRAE 62.1 or Title 24 for ventilation requirement? Johnson Control has developed most of the sequence defined in 2021 edition and is working towards integrating the 2024 editions. Johnson Control is also working with the California Energy Commission to get its application approved. And this will further help ensure that we have a common language in the project. It's not Johnson Controls telling you we did it right, it's a third party. Also, the BAS helps define the relationship between the plants and the loads. An AHU needs to know which VAV it serves. Johnson Controls can provide application templates that defines models of relationship between the terminal units and the plant. Of course, you need to customize the numbers and types of VAV in each zone group. The guideline also specifies testing and commissioning switches for each equipment. On the airside distribution, this can be grouped at the zone level and be overridden at time of commissioning. For instance, force all zone airflow set points to minimum flow or to close, instead of going to each zone individually one by one. Regarding the overall commissioning, many steps remains. Still need to verify all the I/O. Still need to verify that the application is loaded in the right controller, but no need to verify the sequence themselves. They have been validated not only by Johnson Controls, but also by third party. California Energy Commission is one of them. We do need to validate equipment relationship, and we'll still need to do test and balance. But with the testing commissioning switch mentioned before, this can go faster. Additionally, ASHRAE Guideline 36 defines alarms and FDD. Useful feature in this area is called hierarchical alarm suppression. What does it mean? Well, if an alarm is present both at the plant and at the load, the plant is likely the cause of the fault. Let me take an example. If an AHU is unable to meet its supply air temperature set point for any reason, it is likely that the zone will not be able to meet the set points either. Thus, the AHU will disable the alarm downstream so that the operator focuses on the original fault at the AHU and doesn't waste time at each and every VAV box. So, in summary, by creating a common language in the control industry, ASHRAE Guideline 36 enable benefits along the entire building life cycle. It is becoming the law of the land and can anticipate more states to adopt it as part of ASHRAE 90.1. And this is becoming the benchmark that researchers, students, and national laboratories are using to compare alternative solutions. That's all for today. Thank you for being here. We will be happy to welcome you live from AHR for Chapter 2 of this series, where we will talk about deployment. Before moving on to questions, please don't forget to scan the QR code. John, back to you.
Thanks, Bernard. I've got a couple good questions for you. So
Okay.
You ready?
Absolutely.
All right. First one is, how does JCI integrate with different BAS vendor product lines to guarantee that Guideline 36 is maximized?
Today, we are providing a solution that is integral to Johnson Controls, but there are a few parts. There's controller applications, the application for the VAV box, the application for the air handling unit. Those are integral to these controllers. At the system level, we are not providing an integration at this point in time.
Okay, thanks. Next one is ASHRAE 36 referenced in the NFPA codes? If yes, what should fire inspectors look for during a field inspection?
I haven't seen it in the NFPA code. As I mentioned here, I've seen it where elements in the International Energy Conservation Code is using sub-elements of the that are similar to ASHRAE Guideline 36. It's moving its way through the code system. As you know, always take time to go through the entire code system.
Yeah, we both know the codes move really fast, don't they? All right. Next question is there a way to do something similar to Guideline 36 on old N2 systems?
That's a really good question. N2 system is limited in particular with the amount, so by two things is the amount of communication that the bus is able to support. So that's one thing. And the capability of controllers of running such complex application. Basically, only with the newest and most recent application controllers of Johnson Controls, we can run the complete sets of application of ASHRAE Guideline 36.
Okay, great. Here's the next one. How does Guideline 36 affect fan coil units?
So fan coil is one of the application in the guideline. It has, so of course, there's no air distribution, but you could, it account for trim and respond between the cooling coil and heating coil and the central plant.
Okay, awesome. From a controls engineering perspective, what is the biggest challenge in moving the industry towards fully ASHRAE Guideline 36 compliance sequences? Technical limits or something else? It's a good question.
It's a good question. I think the technical limits is we know how to do it, right? There's nothing new, as I said. This is something that we have done in parts over the last 15 to 20 years. So those sequences are here. What I think is needed is what we're doing today, socializing the information, sharing with people, creating this full common language, right? Where we started with writing the spec and writing this guideline. Then when we go into a project, making sure that everybody aligns along the project lines. And I think what California is doing around certifying the application is going a long way into getting all of us speaking the same language. So I would say the technique, yes, we need to learn it, but the human factor is the most difficult.
Yeah, makes sense. Next one. Do you see ASHRAE 36 updating recommended sequences to include DOAS with water loop heat pump systems, as these are gaining popularity in new designs?
Yeah, absolutely. There are the team behind ASHRAE Guideline 36 is working on a continuous basis. I know that DOAS is on the list, but I also know that, for instance, laboratory exhaust system is under review right now and could be happening, maybe not at the next release, but right afterwards. So DOAS is on the list. Heat pump, very high requirement at this point in time. So, you know, it's a matter of time and how much work the industry is putting into it to get to this. I mean, you know, we've done VAV air handling units, central plant with chillers and boilers. It took us basically 12, 15 years now. So the teams are crunching behind all those applications.
Awesome. Next one. What if we send 0 CFM to unoccupied area and use purging frequently? Would it bring more energy savings? I'll leave it at start with that.
So the guideline sends 0 CFM to the space when it's unoccupied, right, already. So the purging is something that would happen in the morning. It is not, purge is not included in the guideline. This is not something that is recommended in the sequence of operation.
Okay. This one's near to my heart as a former rooftop guy. Is the guideline applicable for rooftop units with built-in controllers?
So rooftop is also on the list of application that needs to be done. I think taking a lot of people are saying, well, I can just take the application and move it to a rooftop. I think while the principle applies, there are some limitations that are often overlooked, specifically when we get to the minimum airflows. How far can we go with a DX system at the low end is probably the most questionable part of this implementation. Rooftops are on the list, and I think, you know, I've heard several rooftop manufacturers that are eager and are waiting for the team to come with a solution. It's just a matter of prioritizing which come first and what is the most needed by the industry.
Okay, the next two questions I'm going to kind of bundle together, and it's basically the idea of how can Johnson Controls make it easy to select the appropriate sequences? Are there standard control diagrams or templates included to assist designers and commissioning agents?
Very, very good questions. And actually, during the session at AHR, we will actually demonstrate how easy it is to select and build an application. But beyond that, if you use the guideline itself first, there is a number of IOs that are required. There's, of course, some of them are mandated, some of them are optional. As usual, it's up to the engineers to select the features. So all those tables are available and can be reused. At the end of the guideline, there's all the graphics that are available and that are part of the guideline. Interesting to note is that the ASHRAE Guideline 36 has a Word version at the end that is available, where you can pick and choose, some of those graphics, some of those tables, so that you don't have to copy a PDF document and it all scrambles around. Really, this is making it easy. So the spec, the graphic, this is under the responsibility of the ASHRAE committee. How we make it easy in Johnson Controls, we've already done it all the applications are built, pick and choose the applications, all the sequence logic when we select the application is actually match what the guideline is saying it's doing. But to be fair, we're not at the end yet. There's still some work. As we progress, you'll see some improvement on the tools, on the controllers that Johnson Control is supporting, so that it's becoming second nature, basically, to deploy ASHRAE Guideline 36.
Great. Okay, here's a few more. What is the difference for the operators when Guideline 36 is integrated in controls versus when we implement the sequences manually?
So from the sequence themselves, from the operator point of view, the change that is visible is there's more points that are visible, right? The guideline impose or drive us to have more points shared with the operator. The application itself shouldn't matter as much. I think the part where there is the most difference from an operator point of view is this trim and response algorithm that is helping communicate between the terminal units and the plants, and that needs to be watched fine. So there's a learning experience that exists there that the operator would need to go through. But from the interface of an air handling unit, it still looks like an air handling unit, maybe with more points. From the interface of a VAV, maybe a little bit more points.
Okay. Next one is, this is about indoor air quality. For ozone and wildfire smoke sequencing, is the return to normal based on a manual decision by a field operator, or does Guideline 36 have an automatic return to normal?
So, so this is up to the implementation. There is a requirement to be able to override a damper enables, for instance. This is how it's implemented is the economizer is enabled because the conditions outside from an energy point of view are positive. What the air quality would do is it would override this. Now it's up to you to decide how you want it to be done. You can do it based on a sensor, right? And you would decide of a threshold for that particular sensor that says that at 35 microgram per cubic meter of PM, I want to shut down my economizer, and that would be an outdoor sensor. Or that could be an API with a weather station or an outdoor sensor that gives me the ozone information. And then again, I would define my my system by myself. I don't have to have a manual return.
Okay, great.
But that, it's your choice, basically.
Yeah. Next one. How would you recommend including the ASHRAE Guideline 36 in the control specification to ensure keeping the sequence of operation in a story format so that it can still be used by the building operators as a reference on how the system is to operate?
Whoa. there's a lot of pieces in here. So first, what we do recommend from a specification standpoint is to use as much as possible reference to the Guideline 36. What I mean by this is that there are people that say, hey, we should implement ASHRAE Guideline 36. That is not very helpful. It leads to a lot of RFIs because there's a lot of options to choose from. So the best we can work during the project part is to actually say, hey, we're using the VAV controller per chapter 5.6 and accept maybe one or two points where we want it different because the building warrants it. So that would leave us as close as possible to the to the specification and common language for everybody.
Okay. Is there guidance on adapting ASHRAE 36 for small to medium-sized buildings or retrofits that don't use full-scale BAS systems?
Not at this point in time, to my knowledge.
Okay.
You
Here's
know,
one from,
small buildings are typically are usually multiple rooftops that drives their individual zones, and there's less need for a coordinated effort in a case like this.
okay. Here's one from our friends from the other side of the pond. Do you think they will make Guideline 36 compatible with other ventilation standards such as the UK or EU?
I think this is a very good question. I have been working very closely with our friends in the UK, where the principles are the same, right? But what we see is that the standard, for instance, in the US says we need to have the ventilation based on the square footage of the space, which has a certain amount of ventilation requirement, plus the ventilation depending on the number of people. In the UK, it's based on the maximum between the two. So slightly different strategy, but the principle behind it is we need to calculate what is the ventilation that is needed based on this occupancy that is variable. So the changes might be very minimal to actually go from one to another. I think it will take time, probably not on the priority list. If I go into, do we need more heat pump? Do we need DOAs? Do we need all those types of things? But, the ASHRAE process is open, and if somebody wants to help, everything is welcome.
Awesome. Okay, here's another one that's interesting. Does ASHRAE Guideline 36 retro projects are they marketable? How do you sell this retrofit to a building client? Does the building get any valuable accreditation for implementing this successfully?
So I think where the difficulty to go against existing building is to get a baseline, right? We're reading that ASHRAE Guideline 36 save 30% energy. Well, that's nice to see. That's nice to say, but 30% based on what, right? If a building already has some version of supply air temperature reset or some version of static pressure reset, the amount of saving is not going to be as great as a building that has an older BAS system, and where maybe there the solution is more about a gradual implementation where we do change, well, maybe first the VAV controller and then the AHU, and gradually we build our system and a solution to meet the need of the customer.
Okay, one more for you. How are economizer sequences handled? Does ASHRAE 36 include logic for enthalpy-based economizers or only dry bulb?
All the traditional sequence with enthalpy, dual temperature, single temperature, dual enthalpy, and single enthalpy are available. No change there compared to what we're used to. The only aspect that is changed is that there is an override based on indoor air quality or outdoor air quality, so that we don't bring pollution inside of the building when it's not needed.
Okay, I got one last question for you.
Okay.
This ASHRAE Guideline 36 stuff is great. How do I get started?
Well, there's a lot of things to be done, but I would say that the first thing you should do is call your Johnson Controls account exec that you've been working with for the past years, and he can come and help you with that. The other thing is ASHRAE has some training program available that will allow you to learn the guideline, because to be truthful, the book is a little dry, and we need to understanding the structure is super helpful at the beginning, and that's how I would start.
Great, Bernard. That ends all of our questions. So I think that we're done here, and we appreciate everybody for taking time to listen to us talk to you about Guideline 36, and thank you again.
Thank you.